So we have here ethylamine. So it's called ethylamine. Amine is this NH2, well, it's really a nitrogen that's connected to some carbon chains. I picked this one so that you would see that not all bases are hydroxides. The simplest one of these would be ammonia. Simplest nitrogen that acts as a base would be ammonia. But I just picked this so you would see, okay, if you see some hydrocarbon attached to a nitrogen, that's probably a base. It's probably going to take a proton onto that end. And so just so you get used to it. So we've got ethylamine plus perchloric acid. So this is a weak base. I just write the whole thing. And perchloric acid. So perchlorate is ClO4 minus 1, so 1 hydrogen. These two are going to react. The acid is going to donate a proton to the base. And in this case, you're going to have the H plus stick to this, and then you would have a ClO4 minus. So it looks something like this. Okay, so what you need to do is kind of see that this is one ion and it's big, and this ClO4 is another ion. So that's aqueous. Let's make a net ionic equation. So we have ethylamine, aqueous, plus a proton, aqueous, plus perchlorate, aqueous, yields ethylammonium plus aqueous and perchlorate. Get rid of our spectator ions, which is perchlorate. We only have one thing that's strong here. We have a weak acid and a strong base. We have a weak base and a strong acid. So we're getting rid of that spectator ion associated with the strong acid. All right, so that's our net ionic equation. And we can name the conjugate acid-base pairs that we find here. Notice in the net ionic equation, it is a proton that is really the acid. So we don't really need to name this whole thing, although it wouldn't make sense much without it. So we got HClO4, ClO4 minus. So if perchloric acid is your conjugate acid, and perchlorate is the conjugate base. Here's our base, ethylamine. And ethylammonium is your conjugate, the conjugate acid of that base.